Have you ever just stopped and thought about how wild it is that you can type a few words into a computer and get back a completely new photorealistic image? It feels like straight-up magic. Well, today we're going to pull back the curtain and see exactly how these AI models learn to imagine. Let's get into it.
I mean, just look at this. This whole video of an astronaut was made from scratch. There was no camera, no actor, no film set. It literally started as digital noise, like TV static, and was brought to life just by a simple text prompt. It's absolutely incredible and shows you just how far this tech has come.
So that's the big mystery we're going to unravel in this explainer. How on earth does an AI take a complete mess of random pixels and carefully shape it into something coherent, beautiful, and, honestly, often breathtakingly real?
Okay, so the journey from chaos to creation starts with an idea that's actually kind of backward from what you might expect. It's not about adding stuff, it's about taking it away.
You see, the real secret here isn't that the AI learns to be a painter on a blank canvas. No, it learns to be a master sculptor. It starts with this big block of pure noise. Think of it like a block of marble. And then, very carefully, step by step, it chisels away all the chaos to reveal the image that was hidden inside. This whole process is the heart of what we call diffusion models.
And what's so cool here is you can actually see it happening. We kick things off with total randomness, right? That old TV static. But after just 10 little steps of this denoising, you can start to see something, little hints of a structure. As the model keeps working, the image gets clearer and clearer until, bam, after about 50 steps, a fully formed, realistic picture has emerged from nothing.
This is such a brilliant way to think about it. Imagine you spray perfume in a room. It starts out as a concentrated cloud, right? And then it slowly spreads out. It diffuses until it's just a faint smell everywhere. Well, the AI learns how to do the exact opposite. It takes that faint, spread-out scent of noise and figures out how to reverse that process, pulling it all back together into a sharp, detailed image.
So we get the what. It's removing noise. But how in the world does the AI learn to do that? Let's dig into how it's actually trained.
The huge breakthrough came from a 2020 paper that introduced this concept, denoising diffusion probabilistic models, or DDPMs. And the way they're trained is it's genius. You take a real, perfect image, and you start adding a little bit of noise, then a little more, and a little more, until it's just pure static. The AI's only job is to watch you do that and learn how to undo it, one step at a time.
To really get this, try to picture it. Imagine that every possible realistic image in the universe exists on some kind of complex, twisty surface in a massive, high-dimensional space. When we add noise, we're basically knocking a point off that surface into a huge ocean of static. What the AI learns is a vector field. You can think of it like a giant map of arrows. No matter where you are in that ocean of noise, the AI has learned which arrow to follow to get back to the closest spot on that realistic surface. Okay, so our AI can now turn a cloud of noise into a random, realistic image. Awesome. But this is where the real magic kicks in, connecting our words to this incredibly powerful engine.
And that leads to the next huge question, right? How does the AI go from making just any old realistic image to making the specific one we asked for? How does it understand a corgi DJing at a music festival?
The answer is a concept called latent space. The best way to think about it is like a universal translator or a shared map of meaning. It's a compressed, abstract space where the idea of everything, both images and words, can be plotted as a set of coordinates, which we call a vector.
So in this shared space, the text vector for the word duck, which represents the pure concept of a duck, is located right next to the image vectors for thousands of different actual pictures of ducks. The model learns that even though one is text and one is pixels, they mean the same thing, so they should be neighbors on this giant map.
And this is where it gets absolutely mind-bending. Because these concepts are now just points on a map, you can do math with them. If you take the vector for a picture of you wearing a hat, and then you subtract the vector for you without a hat, the vector you're left with points right at the pure concept of a hat. It's like the AI has learned the visual algebra of our world.
All right, we have the noise removal, and we have the link between words and pictures. But there is one last crucial ingredient that takes these models from being just pretty good to being photorealistic: the secret sauce.
So, it turns out that just gently nudging the denoising process with your text prompt, it's not quite enough. The model tends to play it super safe, and you end up with a blurry, kind of average image
that's vaguely related to your prompt but not really committed to it.
Just look at this example. The prompt is a tree in the desert. With just the basic text guidance, you get the desert part, sure, but the tree is more like a faint shadow. It's too timid. But then, with the secret sauce applied, boom, a gorgeous, detailed tree pops right into existence. So what is this trick?
It's called Classifier-Free Guidance, or CFG, and it's a really clever but pretty simple idea that lets us amplify the influence of our text prompt. It basically tells the AI, hey, I'm serious, pay way more attention to what I actually asked for.
So here's how it works. At every single denoising step, the model does two calculations. First, it figures out which way to go based on your prompt, let's say a cat. Second, it figures out which way it would go if you gave it no prompt at all, the most generic average direction. Then, it finds the difference between those two paths. That difference vector is the pure, distilled essence of catness. The model then takes that cat vector, makes it way stronger, and uses it to aggressively steer the whole process.
So, when you put all of these incredible pieces together, the denoising, the latent space, the guidance, you get something that's genuinely revolutionary.
So let's just recap the whole recipe. You start with pure, random noise. You use a model that's learned a vector field to point the way back to something that looks real. You guide that whole journey using your text prompt, which lives in that same shared map as the images. And finally, you sharpen and boost that guidance with that clever CFG trick.
And the end result of all that isn't just a slightly better image generator, it really represents a completely new way for us to create visual things. This quote just nails it, doesn't it? The barrier to creating stunning visual art is no longer a physical tool like a camera or a paintbrush. It's not even about mastering complex software anymore. The main tool is now language itself, your ability to describe an idea.
And that leaves us with this final amazing question. For the first time ever, we have a machine that can translate our thoughts, our language, directly into visual reality. Now that we've taught machines how to imagine, the only real limit is what we can dream up to ask them. So, what will we create next?